presenter is Allison.
I bet if I were to ask you to name a geological fault, you would probably say the San Andreas Fault in California. That's because it's famous for massive earthquakes that cause a lot of destruction very quickly. It even has its own disaster movie. But did you know faults also exist in Louisiana? If you didn't, it's because they get almost no press coverage, since they move in slow motion. They lack the ability to cause earthquakes in the silly putty-like clay they live in. They may not be in present danger, but they are still causing destruction and not unique to Louisiana alone. In this picture is the Highway 11 bridge located near New Orleans, Louisiana. This bridge crosses a fault. Highlighted in the red is the offset from the up-thrown to the down-thrown side of the fault. Up until fairly recently, the best way to find faults along the Gulf Coast was to build a bridge first. In this map, highlighted in the red is the future location of a $600 million bridge in the marsh in my study area. And in the white, a fault. We want to make sure this doesn't happen to that. What these types of faults do is they cause cracks and instability in infrastructure and architecture. But that is just the tip of the iceberg. They further the breakdown of natural coastal storm barriers, which protect everything we built in major port cities such as Savannah, Georgia, and Houston, Texas. They have huge consequences for restoration efforts, as their subsidence increases water depth, letting in seawater, increasing salinity, and killing marsh plants. So, what can we do about these faults? Well, the only thing we really can do is locate them, so we know where we have to deal with them. As part of a statewide project to assist the Louisiana Coastal Master Plan, I'm studying the physical changes in Louisiana marshland in order to locate surface faults. This will help in identifying vulnerable points along the coast for future environmental restoration and current infrastructure efforts. I'm doing this by examining the physical and mechanical properties of marsh soils. I'm using geologic and mathematical techniques in order to locate faults, and I'm characterizing what they do in the ground and on the surface. What I found is that faults are controlling the placement of lakes, river direction, and water drainage patterns. And these water features control the placement of sediment, and therefore determine which parts of the marsh are disappearing. Faults are such massive features, and humans have no real control over their movement. But what we can do is better our understanding so that we can deal with the consequences of their movement on our infrastructure and environment.